Good day, everyone. Today we are talking about section 7.2, graph quadratics in intercept form. Our targets for today: I can calculate and label the axis of symmetry and vertex of a quadratic equation. I can identify the minimum or maximum value of a quadratic equation. I can graph a quadratic equation in intercept form, and I can convert a quadratic equation in intercept form back to standard form. All right, so we start with what is intercept form? Y equals A times x minus p, x minus q. And so what we do is we are saying that some point P and some point Q on a graph are where the graph intersects the x-axis. So our intercepts are P and Q. And just like before, when the values are inside of parentheses, they are opposite of what appears. So if you see x minus 2, that value is 2. If we saw x plus 3, the value is negative 3. And so when we think about this, our axis of symmetry, well, if we have 2 points, we know these 2 points are mere points, and they are equidistant from our axis of symmetry. So that means the axis of symmetry is going to go somewhere in between them. Well, how do I find the middle of 2 points? Well, I can just add them up and divide by 2. So that's how we find our axis of symmetry. We take our 2 intercepts, we add them up, and divide by 2. So we find the average or the mean of the 2 points. So the axis of symmetry is the average of the points. And again, just like before, the notation for the vertex is ugly. Again, our vertex is a coordinate point. So we have P plus Q over 2. That's how you find the x value. And you plug it in. So again, you plug in x to find y. Again, the math version of it looks ugly, but realize whenever you find the vertex, it's just a matter of plugging in the x value, that is the axis of symmetry, into the original equation and calculating. Most people will say these are pretty easy to calculate. All right, so our intercepts. The first one here, we see x plus 2, so that means the first intercept is at negative 2. So we're going to go plot negative 2 on our graph. We see x minus 4, so the opposite of minus 4 would be plus 4. And so we're going to use the word and. When I put these in commas with parentheses, I'm saying the point negative 2, 4, which would be this point out here. That is not the point that we mean. We mean the intercepts are at negative 2 and 4. To find our axis of symmetry, again, you're going to add them up and divide by 2. So negative 2 plus 4 would be 2. Divided by 2, we're going to get x equals 1. When I graph it, it should make sense that my axis of symmetry is equidistant or in between, exactly in the middle between my 2 intercepts. If it's not, I have to look. Did I plot my intercepts correctly? If so, I must have made a mistake in calculating. But that is one quick check. Again, when I'm going to plug in to find the vertex, I'm literally just going to plug 1 into the equation. So I'm going to have y equals 1 plus 2 times 1 minus 4. You could put this all in your calculator at once. You could say, oh, that's 3, that's negative 3, so y equals negative 9. So my vertex is 1, negative 9. So I'm going to plot 1, negative 9. When you are doing the intercept method, you do not need to make an XY table of points. You by all means could, but you don't have to. All I'm looking for is that you can find the vertex and you can find the intercepts. So then you just draw your smooth curve parabola. I would like you to do the first part Again, the -2 has nothing to do with the intercepts or the axis of symmetry. It only gets used when finding the vertex. So I'd like you to pause the video and try to do this one on your own. Hopefully you found that the intercepts, again, opposite of what we see. So we see +1 here, so it's -1. We see -3 there, so it's +3. So it's -1 and 3. We plot those points. We take -1 plus 3, which is 2 divided by 2, we get 1. So our axis of symmetry is x equals 1. Again, make sure you are drawing that as a dashed vertical line and labeling it. And when we plug it in, we then would actually use this -2 that's out front. Some people, when they're going to find the vertex, they'll actually just go and write over the original problem and say, oh, we were plugging in 1. They'll just go and write over the x and put a 1 in there and calculate and go like this and go y equals 8 that way. I'm fine with you doing it either way, as long as you understand how you are showing your work and your method to get there. And that's it for graphing. We will go over a bunch of these in class just to make sure you got it, but that's the gist of what graphing is. All right, converting to standard form. This is basically all you're going to do is multiply it out. Remember, standard form is y equals ax squared plus bx plus c. So in other words, no parentheses. So, and we've already gone the other way where we've converted from standard form to vertex form, or I'm sorry, to intercept form. We called this factoring. So another term for intercept form, some people will call it factored form. So when doing this, you're going to be given some set of parentheses. So this, like this problem here, y equals -2 times x minus 3x plus 4. The order in which we multiply doesn't matter. So you could go and multiply using area split stack FOIL, multiply those two together, and then distribute -2 to everything at the end. I find that most people make mistakes when doing that. So what I would recommend you doing is distributing that -2 to the first parenthesis. Once I've distributed to the first parenthesis, we've used it up, it's good. And then you still have two binomials that you can use the area, split, stack, or FOIL that you can go ahead and multiply these out. So what I'd like you to do is multiply this one out to finish the problem, and then go ahead and try the next two as well. So pause the video and try all of these and check back. Again, on these, you're going to do your method of multiplying. The first one I did FOIL, the middle one I did split, the last one I did area. Again, if you use area for all of them. If you're a splitter, use split. If you do FOIL or stack, use your method for all of them. I'm just showing a different method on each problem so that I can show different methods again. So again, check your answers. If you have any questions, make sure you come to class ready to ask them. Otherwise, have a great day, everyone.